Okay, the box problem application. I have to tell you, this is one of my favorite problems in this section. We've got a box that we're going to make, an open top box, no lid, out of a sheet of cardboard. Okay, and it's 12 centimeters by 15 centimeters, so just a flat sheet. And the way we're going to get our box is we're going to cut out squares of X units long from each corner, and then you flip up, fold up those sides, glue or tape them together, and you end up with this open box. All right, so let's think about the dimensions here. We have started with 15 across the front, but we cut out an X, we cut out another X. So actually my folded box has 15 minus 2X for this front dimension. This side, well, the whole side started out as 12 centimeters, but again, we cut out X from that corner, X from that corner, so 12 minus 2X is going to be that dimension. Well, how high is the box? I've got X here because that's exactly whatever we cut out is how high we can fold it. So these are my three dimensions for my box. Now the first question is, can we express the volume as a function of X? Well, of course, it's length times width times height. So we just simply take v of x using function notation. Volume is a function of x is equal to the 15 minus 2x times the 12 minus 2x times the x. Now I don't have to multiply this out. I can just leave it. If you wanted to multiply it out, you'd FOIL and then distribute your x. All right, the next question is determine the domain of the function. Well, like we've done in previous examples, if I'm dealing with a context, I have to consider the context. And in this context, I've got dimensions. And what we know about dimensions is they always have to be positive. So I'm going to take each one of these dimensions and set them greater than 0. X greater than 0, that's an easy, obvious one. 12 minus 2x greater than 0. If you do your solving, remember to flip because you divide it by a negative, you get x is less than 6. Now 15 minus 2x is greater than 0 would result in x is less than 7.5. Okay, now all three of these things must be true. All three. The reason I've circled the x is less than 6 is because if I'm less than 6, I will automatically be less than 7.5. The reverse is not true. So in order to satisfy all three conditions here, we are going to need 0 is less than x is less than 6, or 0 to 6. So for the third part of our question here, they want us to graph the function and determine the domain or the dimensions that yield the maximum volume. Okay, so here is our function, and I've already put that in my calculator. And notice what I did. I just put it in exactly as we've written it there. I don't have to worry about multiplying it out for my calculator. As far as my window goes, well, we just discovered in part 2 here that we need our x's to go between 0 and 6. So I went ahead and I put my x's in, left my y's negative 10 and 10. If I graph it, I can see it looked like it went up here, came down here, but I'm missing the interesting part where the maximum is. So remember what we can do. We can go to zoom, and we go down to zoom 0, which is, oops, too far, zoom fit. And hit enter, and that's going to change our y's for us and give us a nice downward opening curve, right? And then it's going to come here, touch, and then go back around and go up again because it's a cubic, not a parabola. All right, but our job is to find the maximum. So we use the calculate menu, second trace, and we're going to calculate the maximum, number 4. And remember, left means to the left of whatever it is you happen to be looking for. In this case, a high spot, enter, and then right to the right of that peak. Okay, good enough. And then I'm going to guess. And when I guess, I get this as my answer here. 2.2 for the x, and y is about 177. Now I've gone ahead and I put this up on the screen here. What that's telling me, my x is my first dimension, that's 2.2 centimeters. How do I figure out the other dimensions? Well, if you look at your box and how it was labeled, it was 12 minus 2x and 15 minus 2x for the other two sides. So we simply plug in 2.2 for the x, calculate, and we get 7.6 and 10.6 for the remaining two sides.